Hello students, good afternoon. This is Ramarao sir, lecturer in physics from IIT Rajendra Nagar. Today I will going to start the concept of electromagnetic induction. It is a very important for JEE mains and advanced. So what is an electromagnetic induction? Electromagnetic induction means due to changing the magnetic flux, an EMF is developed in the same coil. So that is called as electromagnetic induction. Before going to discuss about the electromagnetic induction, first we should have to discuss about the magnetic flux. Magnetic flux. Magnetic flux. So what is a magnetic flux? Magnetic flux means the number of magnetic lines of force passing through per unit area is called as a magnetic flux. Suppose consider a unit surface area or surface area. This is a surface area. ठीक है. So this is a direction of area. This is a direction of area. The lines of forces are passing through like this through this surface area. The magnetic lines of forces are passing through this surface area. The magnetic field induction would be like is there. This area vector is making some angle theta with the direction of magnetic field. This magnetic field would be in the two-dimensional plane, because of which is making some angle theta, no? So this magnetic field can be resolved into two rectangular components. First, in the direction of angle, B cos theta, other than direction of angle B sin theta. This is a B sin theta. Okay, this is a B cos theta. B cos theta would be in the direction of angle. Other than direction of angle B sin theta. B sin theta is not responsible for the flow of the magnetic lines of force. The magnetic lines of force are passing through like this direction only. Okay, along the surface area. So the flux across this area can be defined as B is equal to, what is the B? The flux passing through this area can be defined as so how much flux is passing through the surface area? Let's take a small elementical part here beta ho. This is a small elementical part ले तो small elementical part से कितना flux जा रहा है? dB flux जा रहा है इससे, ठीक है. स्मॉल एलिमेंटिकल का एरिया कितने हो जाते बोलो? स्मॉल एलिमेंटिकल का एरिया क्या हो जाता है बोलो? स्मॉल एलिमेंटिकल का एरिया is a dA which is in the direction which is makes some angle theta with the direction of the field. This is a field direction है, this is a field direction है, ठीक है. This is a direction of the field B है, direction of field B. So the flux passing through this surface area can be defined as how much amount of the flux is passing through this area, that is d phi. D phi is equal to the component of the magnetic field along this direction of area would be is dB cos theta into its area vector. Area vector is nothing but what is that? Area vector is nothing but what is the area vector? Area vector is nothing but A or dA. We have taken dA. But here B only, not B cos theta, here B only. Completely you can consider what is that B only here. B cos theta only B cos theta. This is a B cos theta only B cos theta into dA. How much amount of the total flux is passing through this area? That is we should have to calculate now. The total flux passing through this area is given by integration of d phi is equal to, what is that? Integration of B cos theta into dA. So dA means what is this small elementical area of vector. So this is integration of d pi value is a pi, that is pi would be is equal to B cos theta is constant which is right out of the integration. Then integration of dA. Integration of dA means this total area. What is this total area? You don't know. Let's take the total area of the cross section would be is dA. Okay, that is pi is equal to, what is the pi? Pi is equal to B cos theta into Yes, simply what I am writing, pi is equal to BA cos theta. This is a magnetic flux. Pi of B is equal to BA cos theta is called as a magnetic flux. Suppose if okay, that is called pi of B is called BA cos theta. Its units are, what are the units? Units are Webers. Units are, what are the units? Its units are Weber. Units are units Webers. Units are Weber. Okay. Suppose consider a coil. This is a coil. This is a coil. This is a coil. Okay, which is rotating with an angular velocity omega about this axis of rotation. This is an axis of rotation. So the lines of forces are passing through like this. Lines of forces are passing through like this. Lines of forces, the magnetic lines of forces, or the direction of the field would be like this direction. This is the direction of the field. Direction of the field would be like this. This is the direction of the field. The direction of the field will acting along the direction, and which is rotating like this, the axis of rotation. Therefore, its angular velocity in the form of theta we can write like this. Omega is equal to angular velocity is equal to angular displacement upon time. That implies theta is equal to omega into t. Okay, this omega into t. This value substitute in this equation, then you will get what is that, the magnetic flux pi of B is equal to BA cos omega t. BA cos omega t. This is a magnetic field due to rotation of the coil in a magnetic field of induction B. Okay, magnetic field of induction B is equal to this much. Therefore, due to variation of the magnetic flux across in a coil, suppose this coil is rotating like this. This coil is rotating like this. The lines of forces would be acting along the direction. This coil is rotating like this. When the coil is rotating, the magnetic flux changes across it. When the magnetic flux is changing across it, what happening is there, an induced EMF is developed across this coil. This phenomena is called as an electromagnetic induction. Due to variation of the flux across a coil, an EMF is induced in that same coil. This phenomena is called as electromagnetic induction. It was explained by Faraday. Faraday's. So that's what it is called as a Faraday's law. So what is the Faraday's law? See here. Suppose when it is rotating across this in a magnetic field, the magnetic flux associated across the coil changes. The change in the magnetic flux is induces an induced EMF. That means when a flux has to be changes across the coil like this. This is a coil. When a flux has to be changes across the coil like this. This is a magnetic flux. When a flux has to be changes across the coil, then what happening is that an EMF is induced across this coil. How would be the flux changes? Suppose consider a magnet. This is a magnet. It has a one north pole and second one is a south pole. When a magnet is brought nearer to this coil, when a magnet is brought nearer to this coil like this, the flux associated across the coil changes. The flux changes with respect to time. That is equal to the change of the flux across the coil can be written as d phi by dt. d phi by dt. d phi by dt. This is a d phi by dt. This is a dt, value of dt. d phi by dt. This is the value of dt, d phi by d phi upon dt. The flux changes across this coil. This changing the flux can be generated and induce EMF across this coil. So this is called as a Faraday's law, or simply what I am writing, you can consider one more of the scenario. Suppose consider a what is that, a solenoid. Solenoid ऐसे है, this is solenoid है, this is solenoid. Okay, across this what happening is there, an ammeter is connected like this is ammeter. When ammeter is connected like this, okay, when a magnet is bringing towards the coil like this, when a magnet is bringing towards the coil, what happening is there, the lines of forces across the coil has to be changes. The lines of forces, magnetic lines of forces, the magnetic lines of forces across the coil is changes. When the magnetic lines of forces across the coil is changes, what happening is there, an induced EMF is developed, then induced current flows across this coil. Induced current will be flows across this coil. So the induced EMF developed across the coil would be equal to, suppose E take, E, that is E is direct proportional to minus d phi by dt. E is direct proportional to minus d phi by dt, where minus sign is represent, what is where minus sign is represents the direction of the the direction of opposition of the field. So from this E is equal to what I am writing, where E is equal to some constant minus k into d phi by dt, where this constant value is treated as a 1, that is E is equal to minus d phi by dt. This is called as a Faraday's law. That means whenever there is a change in magnetic flux across the coil, and induced EMF is induces in that same coil. So this is called as a Faraday's law. It was explained by Faraday, where negative sign is represented by the Lenz law, where negative sign is represents Lenz law. Lenz law. So what is the Lenz law? See here, what is the Lenz law? Lenz law states that the direction of induced EMF, this is a induced EMF, the direction of induced EMF is always opposite to causes to produce it. Okay, so this is called as the Lenz law. Negative sign is represented by Lenz law. Lenz law states that what is that, the direction of induced EMF, the direction of induced EMF, the direction of induced EMF, the direction of induced EMF the direction of induced EMF, the direction of induced EMF is always opposite to cause it is called as a Lenz law. This states the Lenz law. Okay, Lenz law states that the direction of induced EMF is always opposite to causes to it. Example, say suppose consider a loop. This is a loop. This is a loop or closed loop or loop. Suppose consider loop. When a magnet of the north pole is moves towards the coil like this, this is a magnet. When a magnet of the north pole is moves towards the coil like this with certain velocity, then what happening is that the flux associated across the coil would be changes. The flux associated across the coil would be changes. When the flux associated across the coil would be changes, then what happening is there, automatically some induced EMF is developed. How much amount of the induced EMF is developed? E is equal to minus d phi by dt. This much induced EMF is developed across the coil. But Lenz law states that the direction of induced EMF is always opposite to causes to it. That means this is the applied magnetic field or B existing. this is a B existing magnetic field. Okay, this magnetic field is changing across the coil while moving the magnets towards the coil, Therefore, induced EMF is developed. The induced EMF is must be opposite to causes to it. That means the induced EMF can be produced as induced magnetic field. Because of whenever a current is flows across the conductor, what happening is there? Whenever a current is flowing across the conductor, according to the Ampere's law, according to the Oersted law, along the length of the conductor, what happening is that the magnetic field has to be generated. Is it clear or not? Similarly, whenever the flux changes across the coil, an EMF is induced. The induced EMF is must be produced some induced current. The induced current must be produced an induced magnetic flux. The induced magnetic flux is must be opposite to causes to it. So, what is the causes for producing the induced EMF? This is applied magnetic flux is the responsible for produced induced magnetic flux. Therefore, the induced magnetic flux is must be opposite like this. In this, some induced current has to be developed. The induced current must be produced induced magnetic flux. This is a B induced. This is a B induced magnetic flux. B induced magnetic flux. This B induced magnetic flux must be opposite to causes to it. Okay. So, what is the direction of current? The direction of the current would be like this direction, anti-clockwise. This is anti-clockwise direction. This is a direction of the induced current. How can we calculate the, how can we determine the direction of current? We can determine the direction of current by using the right hand palm rule. Okay. See here. What is the right hand palm rule? See here. This is a coil. Okay. A magnetic field is applied like this. This is a B existing or B applied magnetic field or B existing magnetic field. Okay. So, for the B existing magnetic field is must be produce an induced current. The induced current must be produce an induced magnetic flux. The induced magnetic flux is must be opposite to causes to it. That means the induced magnetic flux is must be opposite like this. This is a B induced. A right hand is situated such that the thumb is pointing in the direction of the induced magnetic flux. Then the remaining curled fingers, these are curled fingers. The remaining curled fingers are gives the direction of the flow of the induced current in that coil. That means the existing magnetic field will act along the direction. Because of it, it is must be opposite to the existing magnetic flux. Therefore, the remaining colored fingers would be like is there. So, the remaining colored fingers would be like is there. This is the remaining colored fingers. The remaining colored fingers would be like is there. The remaining colored fingers like is there. So, this is the direction of the flow of the current. Okay. So, this is called as a Lenz law and this is called as a Faraday's law. So, this is called as the direction of the determine the direction of the induced EMF or induced current in an coil. Okay. Next, see. Suppose consider a coil. This is a coil. Suppose consider a coil. This is a coil. Okay. Which having the resistance R like this. Which having the resistance R. Across this, what happening is there? Across this, the flux is changes like this. Across this, the flux is changes. Across this, the flux is changes like this. So, magnetic flux has to be changes like this. Across this, the magnetic flux has to be changes like this. This is a pi of B. Okay. When the magnetic flux changes across this, what happening is there? And EMF is developed in that same coil is already know according to the Faraday's law. Okay. So, according to the Faraday's law, what happening is there? E is equal to minus d phi by dt, d phi by dt. But what is the value of pi? Pi value also already know. Pi is equal to what is the pi? Where pi is equal to BA cos omega t. if the coil has only one turn, the coil has only one turn, for n turns, for n number of turns, for n number of turns, what is the value of pi is equal to Na B cos omega t. Okay, if the coil has n number of turns, then the magnetic flux associated across the coil can be given as pi is equal to NAB cos omega t. NAB, this is a n value, this is the value of n, 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 NAB cos omega t. Okay. So the induced EMF across this coil is given by E is equal to minus d phi by dt. D by dt of what is the value of pi? Pi value is NAB cos omega t. NAB cos omega t. Therefore, this is what I am writing. E is equal to minus NAB cos sin omega t, whatever this value, sin omega t minus sin omega t, minus will become positive, sin omega t, that is equal to sin of omega t into the derivative of omega t value is omega, that is E is equal to NAB omega sin of omega t. This is what I am writing. E is equal to E naught into sin of omega t. E is equal to E naught into sin of omega t, where E naught is called as what is the value of E naught? Where E naught is called as E naught is equal to NAB omega is called, what is this called? NAB omega is called as maximum EMF. What is this called? Maximum EMF. Maximum EMF. When would be the EMF is maximum? From this equation, see. When would be the EMF is maximum? If omega t is equal to what is omega? If omega t is equal to 90 degrees, then this equation would be E is equal to what is that? NAB omega. NAB omega, it is a very, very important. Mains level questions are asking based on this concept. Okay? This is a maximum EMF. Okay? But instantaneous EMF, what is the instantaneous EMF? Instantaneous EMF is E is equal to E naught into E is equal to E naught. E is equal to E naught. What is E naught? E is equal to what is the value of E? E is equal to E naught into sin omega t. Okay, E is equal to E naught, or E is equal to E naught means d phi by dt. E is equal to minus d phi by dt. I am writing like this. Okay, minus d phi by dt. But E, what is the pi? Pi is called B dot A. What is the area? This area is equal to this is a, let's take the area of the loop is A. The magnetic flux would be is a pi of B. Field is a B. Therefore, E is equal to minus d by dt of B dot A. B dot A. B dot A, that is equal to BA cos E is equal to minus BA cos. Directly you can substitute this value, no problem at all. Directly you can substitute this value. E is equal to minus d pi by dt means pi value also already know. What is the pi value? NAB omega is already knows. That is equal to E is equal to what is the value of EC? E is equal to minus d by dt of NAB cos of omega t. Cos of omega t. ठीक है. This is one of the standard formula for solving the different types of the problems in JEE Mains. Okay. Suppose if the A changes, then the remaining all terms as treated as a constant here. If A changes, suppose if the A changes, the remaining all terms are treated as a constant, that is E is equal to minus NB cos omega t into dA by dt. If A changes, this equation we will have to write like this. Suppose if the B changes, in the same scenario, E is equal to minus NA cos omega t into dB by dt. If the B changes, the above equation we will have to write like this. Suppose the theta has to be changes, then E is equal to minus NAB d by dt of cos omega t. D by dt of cos omega t means this also we will have to write like this. E is equal to minus NAB into cos theta 1 or cos theta 2 minus cos theta 1 by dt. So this is we have to use when A changes, area changes. When area changes, then we can use this one. If B changes here, when B changes, we have to use this equation. Suppose if theta changes, if function of cos theta changes, then we have to use this formula. ठीक है देखो. So this is a induced EMF in different forms. Okay, this is also I am writing like this. See here, in the form of a resistance. Whenever the flux changes across this, what happening is that the current will be flows. Existing magnetic field must be produced like this. So what is the direction of current? Direction of current will be like is that. This is the direction of current. Direction of the current will be flows like this direction. Because of the induced magnetic flux, B induced is must be opposes the existing magnetic flux. Okay? Therefore, in the form of resistance, the magnetic flux can be written as E is equal to what is that? E is equal to minus d phi by dt. Okay, but E is equal to IR, no? IR is equal to minus d phi upon dt. So from this I is equal to minus 1 by R into d phi upon dt. This also what I am writing, see here, minus 1 by R into pi 2 minus pi 1 upon dt, or simply this is what I am writing, I is equal to minus 1 by R into, you should remove minus value, then what you will getting, see here, pi 1 minus pi 2. From this it is very clear that pi 1 minus pi 2 upon dt. This is what I am writing simply, I is equal to delta phi upon R into dt, This much induced EMF has to be induced across this coil. Okay. So due to this induced current, how much amount of the charge can be flows across the coil? That is we should have to calculate now. So this current I am writing in the form of a charge. What is the current? The rate of change of charge with respect to time is called as the current, is already known. That is I is equal to dq by dt. That is equal to delta phi upon R into, this is also dt I am writing. Okay. On both sides, what would be the common? Dt would be the common. You can cancel out those dt on both sides. Therefore, you can do integration. Integration of dq is equal to 1 by R into integration of delta phi. Okay. So from this integration of dq means total charge q is equal to 1 by R into integration of delta phi. So this much amount of the induced charge has to be induces. This much amount of the induced charge has to be induces across this coil. Okay? This much amount of the induced charge has to be induces across this coil. So these are the different forms of a induced EMF while the flux changes across the coil. It is also very important for JEE mains purpose. It is also very important to solve the problems in JEE mains and advanced. Okay, ठीक है, लिखो. So based on this concept, see one problem. Suppose consider a conducting loop. A problem, see the problem, JEE mains problem. Suppose consider a conducting loop है बेटा, वो भी conducting loop है. This is a conducting loop. This is a conducting loop. Conducting loop. Okay. Here you should remember, when a loop is given, what is its area and what is its plane. Those two things you should have to identify is the most important here. See, first we should have to discuss about that. Okay. Suppose consider what is that? This is a loop, closed loop. This is a closed loop. This is a closed loop. The loop would be like is there. This is a loop. The loop would be like is there. This is a loop. Okay. Area vector will be like is there. This is a area vector. Area vector will act along the direction. This is the plane of the loop. This is the plane of the loop. This is the plane of the loop. This is a plane. This is a plane. This is a plane of the loop, and this is a area of the loop. Area of the loop. Area of the loop. This is a plane of the loop. Okay, is it clear? Area vector and plane both are mutually perpendicular to each other. They would be perpendicular to each other. Area vector and plane vectors, both of them are mutually perpendicular to each other. ठीक है? Those things you should have to remember here. Next, see, suppose consider a conducting loop. This is a conducting loop. This is a conducting loop. Problem, see, this is a conducting loop having the radius r. This is having the radius r. ठीक है? So this which is placed in a magnetic field here, beta, outside magnetic field. The outside magnetic field will acting like this. That means area vector like is there. This is area vector. The outside magnetic field will acting across this. This is outside magnetic field. The outside magnetic field will acting like this. This is a outside magnetic field which is acting outward like this. The direction of the lines of forces will be outside the plane of the paper. This is a outside the magnetic field will acting outward direction like this. The direction of the magnetic field would be outside direction is there. Okay. And this radius vector is changes with respect to time. As a function of time, r is equal to r naught plus t square. This radius vector, that means the loop is sometimes expanding like this. The loop is sometimes expanding like this. The loop is sometimes expanding like this. When the loop is expanding like this, the magnetic flux associated across the loop will be changes. Is it clear or not? When the loop is expanding like this, radius vector is changing like this. R is equal to r naught plus t square means what is the meant there? When the loop is expanding means the magnetic flux associated across the coil will be changes. When the magnetic flux across the coil will be changes, automatically what happening is there? Some amount of an induced EMF is developed across the coil. So that is we should have to calculate now. ठीक है? This is a IIT problem है, advanced level problem. Advanced level problem है ना देखा? देखो. So find the when area vector is changes r is equal to r naught into 1 plus t square, then find the induced EMF, induced EMF across the loop, as shown in figure, वो फिगर ऐसा दिए, इसमें क्या क्या करना पड़ता है, इंड्यूस्ड ईएमएफ निकालना पड़ता है। ठीक है, देखो बेटा नोट करो, किए नोट किए, ठीक है। चलो दिस लूप दिए बेटा, प्रॉब्लम में क्या दिए, वो भी लूप ही है, सर्कुलर लूप है, इसका रेडियस चेंज हो रहा है, ऐसा रेडियस हैज टू बी चेंजिंग विथ ए फंक्शन ऑफ टाइम, r इज इक्वल टू r naught plus t square। ठीक है, the magnetic field will acting outward direction है बेटा, this is direction of magnetic field है, the magnetic field acting outward direction है, this is direction of magnetic field acting outward direction। okay, now we should have to calculate what is that induced EMF across this coil। ठीक है, कैसा करना पड़ता है, देखो the induced EMF कैसा करना पड़ता है, existing magnetic field outward direction है, okay, the induced magnetic field must be inside act करना पड़ता है। so what is the direction of current, the direction of the current will be flows like this in clockwise sense, direction of current will be in clockwise sense है, I is a clockwise sense, I is flows clockwise sense। ठीक है, so due to that what happening is there, the induced EMF is given by E is equal to magnitude of d phi by dt, I am writing magnitude of d phi by dt, that is E is equal to d by dt of this pi value, what I am writing, pi is equal to b dot a। okay, here see area vector same direction है, b vector भी same direction है, theta is 0 हो जाता है, cos 0 value is 1, so that's what I have written b dot a, that is a ba cos theta, theta value 0, cos 0 value 1, that is called ba, I have written like this। ठीक है, मैग्नेटिक फील्ड ऐसा है बेटा, ऐसे दिस डायरेक्शन ऑफ द मैग्नेटिक फील्ड है, दिस डायरेक्शन ऑफ एरिया है, magnetic field and direction will be having in the same direction। okay, what is the angle between them, where theta is equal to 0 now, pi is equal to, what is the pi, pi is equal to ba cos theta, already knows cos theta, where theta value 0, that is pi would be is equal to ba into cos 0, cos 0 value how much beta, what is the value of cos 0, 1, that is pi is equal to b dot a, I have written directly here, pi is equal to b dot a, is it clear? So what is the b, b is a constant, b does not changing, so what is the changing in this problem, वो प्रॉब्लम में क्या चेंज हो रहा है, ओनली रेडियस वेक्टर ओनली चेंजेस, ओनली रेडियस वेक्टर ओनली चेंजेस इसमें। ठीक है, देयरफॉर E इज इक्वल व्हाट आई एम राइटिंग, सी E इज इक्वल बी कांस्टेंट d by dt of A means what I am writing, pi r square, area of this loop A is equal to pi r square is already knows, okay, that is E is equal to b into d by dt of pi, also write out of the derivation, r value was given r naught plus t square है बेटा of whole square, is it clear? So from this what I am writing, see here, E is equal to pi into b d by dt of r naught plus t square, r naught is a constant here, where r naught is a constant, it does not change, which is a constant, only t square only changes with respect to time, okay, this is what I am writing, see pi into b, this is what I am writing, see E is equal to pi b into d by dt of r naught plus t square, derivative is a 2 into बोलो 2 into r naught plus t square into 2t हो जाता है, derivative of t square is a 2t, okay, d by dx of, because of d by dx of d by dx of x power of n dx is equal to n into x power of n minus 1 is already knows. Like that I have expanded like this. Okay. Therefore, the induced EMF is given by E is equal to what is that? What is the value below? 4 pi b t into r naught plus t square. This much amount of induced EMF is induced across the coil. Okay. So, what is the direction of current in this? See here, existing magnetic field is the outward direction is there. Therefore, induced magnetic flux is must be opposes the existing magnetic field. That means the induced magnetic flux is must be like this, inside direction is there. It must be acts inside direction. So, direction of current will be like this direction. The remaining colored fingers are gives the direction of current. No, this is the direction of current. Direction of current which is a clockwise sense. Clockwise. This is a clockwise sense. The direction of induced current would be clockwise. The direction of induced current would be is clockwise. Okay. So, what is the direction of induced current? Yes, see. Direction of induced current how can be read? Suppose if the loop has some resistor of resistance R. Okay. इसमें डायरेक्शन ऑफ इंड्यूस्ड करंट को कैसे निकालना पड़ता है बेटा? E is equal to IR है ना? This is IR is equal to 4 pi b t into R naught plus t square. So, from this I is equal to 4 pi b t upon R into R naught plus t square. This much amount of induced current has to be induced across this coil. ठीक है? Is it clear or not? बहुत आसान है. कोई भी प्रॉब्लम दे तो ऐसा करना पड़ता बेटा. और जे मेंस का एडवांस लेवल प्रॉब्लम है. ठीक है? नेक्स्ट और एक प्रॉब्लम देखो सेम कॉन्सेप्ट में. और एक प्रॉब्लम दिस आल्सो एडवांस लेवल ओनली. एडवांस लेवल देखो. सपोज कंसिडर ए लूप. दिस इज ए लूप है बेटा. दिस इज ए लूप है. दिस इज ए लूप. ओके. The flux is increases across the loop like this. The magnetic flux is increases across the loop. The magnetic flux is increased towards the loop like this. The magnetic flux is increased towards the loop like this. Okay. When a magnetic flux is increased across the loop, what happening is that induced current and time relation graph was given like this. The induced current and time graph was given like this. Here 0 to T1 दिए, T1 to T2 है, T2 to T3 ऐसा दिया बेटा. This is a direction of induced current and time है. Induced current I and with respect to time कैसा change हो रहा है induced current है बेटा. इधर टाइम इज को 0 ले, इधर t1 सेकंड्स ले, इधर t2 सेकंड्स है, इधर t3 सेकंड्स वाज गिवन. ओके. हियर सी 0 to t1 what happening is there when the flux is increases. When the flux is increases, what happening is there? See, when the flux is increased, that means when a magnet or external existing magnetic field is bringing towards like this. Okay, is it clear? When the magnetic flux is increased towards the coil, there must be an induced magnetic flux that has to be induced. The induced magnetic flux is must be opposites in the direction of existing magnetic flux. Okay, this is a existing magnetic flux है बेटा. This is a B existing. So, the induced magnetic flux is must be opposite to causes to it. This is a B induced. The induced magnetic flux is must be opposite to causes to it. That means existing magnetic field would be like is that. Loop ऐसा है बेटा. Loop ऐसा. Current कैसा हो जाता है? Current ऐसा है. Current ऐसा हो जाता है. Anti clockwise direction है बेटा. First, when a magnet is approaching towards the coil, the direction of the current would be in anti-clockwise direction. Okay, ठीक है. इसमें देखो from 0 to T1 करंट क्या हो जाता है बेटा? 0 to T1 एंटी clockwise direction. When it is entering into the loop, T1 to T2, B is equal to constant. B is equal to constant because of when the magnet has to be enter into the loop. Loop ऐसे बेटा, loop ऐसे, magnet अंदर है ऐसा, magnet is inside is there. When the magnet is inside the loop, there is no change in magnetic flux. That means pi is equal to constant. When pi is equal to constant, what happening is the induced EMF from T1 to T2 क्या हो जाता है बोलो? The induced EMF from T1 to T2. Induced EMF from T1 to T2 E is equal to बोलो minus d phi by dt है ना? बोलो. That is equal to magnitude of minus d phi by dt है बेटा. That is equal to d by dt of pi value is constant. That would be is equal to 0. Induced EMF is 0. That means induced current will be also 0. That is IR is equal to 0. That means IR is equal to 0 means I is equal to 0. There is no flowing any amount of current from T1 to T2. Current would be is equal to 0. Is it clear? Next see T2 to T3. T2 to T3 means the magnet is, what happens, the magnet is moving away from the loop here, away from the loop. When the magnet is moving away from the loop, this is a north pole and this is a south pole beta. When the magnet is moving away from the loop, aisa. When the magnet is moving away from the loop, the flux is decreases. When the magnet is moving away from the loop, what happening see here? In the third case, the magnet is moving away from the loop, north and south. Then what happening is that the flux is decrease across the loop. When the flux is decrease across the loop, the existing magnetic field also acts in the same direction, opposite direction like this. Then what happening in the same direction है? Existing magnetic field this direction है. Induced magnetic field would be is equal to this direction है. Then current कैसे जाता है बेटा? In clockwise sense जाता है. The current will be flows in the direction of clockwise sense from T2 to T3. Okay, ठीक है. Therefore, in this case, when we have drawn the graph, finally see here, from 0 to T1 anti-clockwise है बेटा, 0 to T1 anti-clockwise ऐसा हो जाता है, ठीक है. 0 to T1 anti-clockwise. Next to T1 to T2 there is no current. T1 to T2 there is no current. Next to T2 to T3 क्या हो जाता है बेटा? Current would be is in clockwise sense हो जाता है. This is a clockwise, this is a anti-clockwise sense, this is a clockwise sense. So this is the direction of the flow of the current with respect to time. ठीक है? Understood or not? Understood or not? बोलो. Understood or not? Is it clear or not? So this is a shape of the graphs. This is an advanced question है बेटा. 2016 में पूछे, बहुत आसान है. Next देखो, suppose consider 2025 में क्वेश्चन पूछे इधर देखो. Suppose consider a coil. This is a coil. Okay. Has a radius r, which is rotating with an angular velocity omega about an axis of rotation. Okay, area vector will be acting outwards the plane of the paper, and this plane will act. This is the direction of the plane. This is the direction of the plane. This is the direction of the plane. Okay, area vector will acting like this direction. Area vector will acting along the direction and which is rotating like this. ऐसा rotate कर रहे हैं. Direction of the magnetic field ऐसा है बेटा. This is the direction of the magnetic field ऐसा है B will be acting along the direction. When it is rotating like this, when the plane of the coil is parallel to, magnetic field, that means when it is rotating like this, at certain instant of time, what happening is there, this plane of the coil, this is the area vector, this plane of the coil is parallel to plane of the coil, plane of the coil is parallel to magnetic flux B. So what is the angle between them? The angle between the plane of the coil and magnetic flux would be is equal to 0. Therefore, in this case, calculate the EMF and magnetic flux associated across the coil. This is 2025. This is JE 2025 में पूछे बेटा, बहुत आसान है. देखो, a coil is rotating about this axis of rotation in a magnetic flux. At certain instant of time, its plane has came parallel to the what is that magnetic flux. Then in that case, calculate what is the flux associated across the coil and induced EMF. So what is the flux associated across the coil? बोलो pi is equal to NAB cos theta ना, cos theta, NAB cos, okay ना. But theta is equal to 0, that is pi is equal to NAB cos 0. Cos 0 value is 1, that is pi is equal to NAB. So what is the value of E? E is equal to minus NAB cos NAB omega, बोलो NAB omega sin omega t. Sin omega t है बेटा, sin omega t. Omega t means where theta is equal to 0, E is equal to 0. Flux is equal to NAB. Next, what is that? EMF E is equal to 0. ठीक है, बहुत आसान प्रॉब्लम है. ओके ना? Okay. If you have any doubt in this concept, please ask me. Especially, if you have any doubt, call me. I have my number is no need.
Scrolling number is
Picture, okay. If you have any doubt, call me. So the on scrolling number. ठीक है.
సో ఇప్పుడు జరిగిన క్లాస్లో మీకు ఎటువంటి డౌట్స్ ఉన్నా కానీ మీ స్క్రీన్ పైన ఒక నంబర్ స్క్రోల్ అవుతుంది. ఆ నంబర్కి కాల్ చేస్తే ఇక్కడ మీకు సారు ఆ డౌట్లని క్లారిఫై చేస్తారు. అదేవిధంగా అక్కడున్న టీచర్లు, ప్రిన్సిపల్లు విద్యార్థులకి ఆ నంబర్కి ఫోన్ చేసేటట్టు హెల్ప్ చేయాలని కోరుకుంటున్నాం. సో ఇప్పటివరకు జరిగిన క్లాస్లో విద్యార్థులకి ఎటువంటి డౌట్లు ఉన్నా కానీ ఆ నంబర్కి కాల్ చేస్తే సారు మీ డౌట్స్ క్లారిఫై చేస్తారు.
Do you have any doubt? Please ask me. Do you have any questions? Ask me about this. What is that magnetic flux and Faraday's law and Lenz law? It is very, very important for the JEE mains and advanced EBET. Okay. You should have to learn like this in the slowly process. Then automatically you will get very good score in JEE mains. Okay. Any questions? Do you have any questions? Please ask me. Do you have any questions? Okay. ఏమైనా క్వశ్చన్స్ ఉంటే అడగండి. అంటే ఏమైనా డౌట్స్ ఉంటాయి లెన్స్ లా పైన కానీ ఫారడేస్ లా పైన కానీ మ్యాగ్నెటిక్ ఫ్లక్స్ పైన కానీ ఏమైనా డౌట్స్ ఉంటాయి JEE మెయిన్స్ ఆర్ అడ్వాన్స్ లెవెల్. ఓకే. Okay. Okay, thank you guys.